On this episode of Global Topic, I'll have a conversation with Professor David Bastidas, Associate Professor at the University of Akron in Akron, Ohio. Professor Bastidas and I will have a conversation on the topic of corrosion of steel and reinforced concrete. Welcome to Global Topic, the go-to series for the global corrosion and protective coatings industries, exclusively here on YouTube. In this series, you'll find technical content, information, and the latest industry news and events. And now for our interview. Professor Bastidas, welcome to Global Topic.
Hello, Jim. Thank you so much. Thank you for the invitation. I really appreciate giving the opportunity to talk to you and talk to the audience.
Hey, for the viewers, could you please cover the mission and purpose of the National Center for Education and Research on Corrosion and Materials Performance, or NCERCAMP, that is from the University of Akron in Akron, Ohio, USA?
Sure. We're a national center. We were established roughly 10 years ago. That was a mission of the Department of Defense, DoD. We got some financial support. And basically, the driving force was to establish the unique across the nation bachelor in corrosion engineering. That was because the need that was detected on providing specialist expert to fight against corrosion, help society.
You know, globally, steel reinforced concrete is the number one material that's used in infrastructure and other structural construction. You know, what critical role does steel provide in reinforced concrete?
That's a very good question. Actually, concrete itself, this is a ceramic material. It is known that it works perfectly under compression stresses. But when we talk about tensile stress, that no longer provide a very good performance. That's the reason why we produce this composite. Adding in within the structure, we provide these embedded reinforcements, thus imparting, conferring the structure a better mechanical performance. There are mainly two different ways to do that. You can use press stress, so where these tendons, that could be a multi-axial cable or a rebar, is being press stressed in order to better improve mechanical behavior, or you can manufacture your reinforced concrete in traditional way without press stress. So basically, this is again to improve mechanical performance of the reinforced concrete structure itself.
So let me ask you, why does steel and concrete, why does it corrode, or why does corrosion take over?
The corrosion of reinforced concrete typically is something that we don't think it happens, since the reinforcements, they are protected by the concrete cover. But actually, it's one of the main issues of the threat and integrity of the structure. So degradation of the reinforcement is caused mainly because the ingress of aggressive species. Those are in nature typically CO2, carbonation, and chlorides. Difference in between the carbonation is ingress from the environment that typically follows first peak load. This is steady state, and it leads to a uniform corrosion. While in the case of the chlorides, those they are governed by a second fixed load. This is a non-steady state, and they lead to what we know as a pitting or localized corrosion. Once corrosion starts, there are different stages during the corrosion process. One is the initiation, incubation, initiation, and propagation. Okay, so before the passivity breakdown, what is happening is that the chloride at the interface, they reach a certain threshold, the chloride threshold, that is the risk. Typically, this chloride in carbon steel is run about 0.4. This is why commercial cementitious materials, the typical Portland, it is regulated by law that the chloride content needs to be lower than 0.4. So you cannot sell any cement if the chloride content is bigger than that. All right. So one corrosion star, there is the passivity breakdown and then the further propagation. So what is the reason for that? The reason is that the oxides and iron oxohydroxide, they exert a high pressure. So the recrystallization pressure of this oxohydroxide, they produce these expansion forces, right? Thus, what we suffer in the reinforced concrete is a loss of adhesion, is a delamination, is a spalling, is cracking, and then further ingress because of the cracks. It is easy for the external edges to get in through. So it's kind of an autocatalytic problem. Okay, when these chlorides, they are also producing what we know as the iron acid hydrolysis. So that is producing a local, very low pH, so a local acid pH. Okay, we need to remember that. I probably need to tell our audience that in reinforced concrete we have very high pH, so it's a very high alkalinity. Typically, pH is around about 12.6. This is conferred by the Portlandite. So the name of Portland gives the name to the Portlandite. Portlandite is chemically the compound known as the calcium hydroxide. Okay, so this is the Ca for calcium OH2. This high alkalinity in the Purvey diagram lead to a passivation. So we are under protection condition, let's say. When passivity breakdown, basically what we got is a decrease on the pH. And then we no further continue experiencing this protection on the surrounding.
When corrosion starts to impact steel reinforcement in structural concrete, how does the corrosion process impact the overall functionality of the concrete?
So as I previously mentioned, because of this loss of adhesion, so it is important, right, to preserve the integrity of the structure, basically because the functionality of the reinforcement is to impart a better mechanical properties. So when those oxohydroxides start to grow on the interface, on the surface of the rebar, what we got is that no longer we have this adhesion. In addition to this problem, what we lost is this strength, okay? So we are producing this delamination, further espalation, and leading to cracks. When we got the crack, no longer we have any integrity on our structure. And that will just produce the further ingress of external agent that they will also increase the kinetics of the corrosion process. So we need to preserve the integrity of the rebar. We need to think about protection strategies, okay? There have been different strategies, okay, that we can probably go into detail a little bit further. That will be probably one of the now in use alternative reinforcements, alternative metals, like, for example, the use of a stainless steel reinforcement.
What research has NCERCAMP done on steel corrosion in concrete?
We're currently very active. We're covering different subjects, different topics within the whole research area of the reinforced concrete and the corrosion of steel reinforcements. We have done a lot of efforts. We recently produced a new patent on the development and synthesis of novel, smart, microencapsulated corrosion inhibitors. So this idea was based on the current drug delivery to our body. So I think about, right, I mean, if we can treat our pain on our back, on our spine, I'm trying to mimic this spine on our back to the reinforcements on the concrete structure. And I say we need to do something that can stand for longer, that can provide a long-lasting effect while also trying to be environmentally friendly. So we came up with a new formulations for those microcapsules. We have those containers, those vehicles, and we load them with the corrosion inhibitor, okay? We are using different corrosion inhibitors inside, and the most important is that we have found that we have a kind of a synergistic effect. So it's not just the corrosion inhibitor inside, the one is protecting, but also the organic nature of this shell is also imparting a corrosion protection and acting as an oxygen scavenger. So that's one of our main lines on this side of the sciences. On the other hand, we are working on a development and a study on corrosion of new geopolymer concrete. Okay, this is environmentally friendly. This is a green concrete. This is typically made from cementitious materials using the pozzolanic traditional. So typically what we're using now is the fly ash. This is a byproduct from the power factory, power industry. And what we need to do is we need to activate it using alkalis in order to provide this hydraulic property to produce this setting and the curing, okay, in order to harden it, right? So that's been proven to produce very, very good results. So we can see now that the diffusion, immigration, and the pH are different. This is a completely different system, different interface, so it's providing good. In addition, we have our main third line is based on the mechanical properties influenced by corrosion. So we are doing stress corrosion cracking on new stainless steel reinforcement, focus on the lean duplex stainless steel with a low nickel content, since the nickel price experienced a high fluctuation on the stock market. We want to reduce this price in order to be competitive for the manufacturers and help them to introduce in our current and existing structures.
So, based on yours and in the universities, the center's research and testing to protect steel and concrete, what options are available to asset owners to control or mitigate corrosion in the reinforcement steel of concrete?
Well, let me try to help and explain different options. So one of the most widely used is the use of coatings. I'm sure you have all of you have already seen this green staff coating. This is Valspar. Recently, Valspar was bought by Sherwin-Williams, and this is being proved to provide a very good protection against corrosion. Okay, so painting, of course, is one. You can paint the rebar, right? You can also provide an outside coating to the concrete itself, to the ceramic. Okay, basically what you need is to control the penetration of any aggressive species, the penetration of also of the water, of your electrolyte, and the oxygen, of course. Okay, so that's one alternative. More recently, as I previously mentioned, the use of stainless steel reinforcements, that's another good alternative. Okay, but this is something, as I previously mentioned, is probably needs more manufacturing. Okay, so it's not just something that you can do at home, let's say. Okay, but it's super effective, right? Other alternative is the use of corrosion inhibitors, but this is as well something that for doing at home probably is not right straightforward. Okay, we need to use these cementitious materials. You can repair using novel cementitious material and including these mixtures, these novel corrosion inhibitors. Okay. In addition to that, there have been also a lot of studies, and currently used is the use of cathodic protection. Okay, the cathodic protection is another technique, probably one of the most efficient as a palliative. Okay, so if we want to protect an existing structure, I'm pretty sure one of the most effective way will be cathodic protection. Probably not the cheapest one. Okay, since we need to apply current using a DC method for a long time, so continuously, but it's very effective. In addition, there are two extra protection strategies. One is the electrochemical chloride removal. So again, typically pretty similar to the cathodic protection, we apply an external current field, electric field, and what we promote is the diffusion of the chloride. So we're trying to remove the chloride from an existing structure. Okay, and the other one, and in the same line, is what we know as the electrochemical realkalinization. So again, using an electrical field externally apply it, we are trying to provide to reset the original alkaline pH of the structure. Basically, this is the reason why the structure has been threatened. Okay, is this decrease on the purvey diagram on the pH is leading to an active size on the corrosion. So we have a pretty good and widespread options. So now it just depends on the consumer, on the availability, and on the ability also of the technicians to use them.
Very informative. Professor Bastidas, what a great conversation, we're having. In closing out this episode, is there anything that we didn't cover that you would want to leave with the viewers?
Well, I would like to let you know, everyone, about how powerful is our corrosion engineering bachelor. So as I mentioned, it's the unique across the country. So if you need a corrosion engineer, don't hesitate to contact Akron. We have a very, very well cultivated people. They have a lot of hands-on experience. You can also contact us if you want to offer or be part of our co-op program. And definitely, if you have any problem where we can help you at an industrial level, any type of university, governmental institution, we are here to help society. We are here, and NCERCAMP is here to fight against corrosion. And we always have under the umbrella of the University of Akron. Thank you so much.
That's great. And for the viewers, I will have links to the university's center for the NCERCAMP. Also, too, I will have the professional profile on LinkedIn for the professor if you would want to connect with him on LinkedIn. Professor, thank you so much for this opportunity to have a conversation with you today.
Thank you so much, Jim. Anytime.
Hey, have a great day.
You too. Thank you. Bye now.